So this lecture is on data transmission and capturing transmission of data, so listening on the wire. And so here's what we're talking about. We're talking about data transmission. So think back to OSI model and TCP IP model. We're definitely going to be referencing those. We're going to talk about packet sniffing, actually listening to what's traveling over the wire and taking a look at that with some tools. Again, we're going to look at the actual tools to pick apart what's happening over the network, as well as some tools to establish connections and listen for connections. And finally, we'll talk very briefly about what encrypted traffic is going to look like for us. We're not really talking too much about encryption. That'll be later on this week. So data transmission. Here we have your computer right here, assuming some kind of wireless network. You've got your wireless access point slash switch slash router all in one device, probably a modem there too, depending on how your stuff is set up. And then somehow we send that information out to some servers somewhere to give us a response, right? So our computer will act as a client, and out there somewhere else, there's some other machines that are going to act as a server for us. And we're going to talk about how you actually send that data across now. Go away. Cool. So the big idea that I want you to kind of get in your head is this idea of data encapsulation. So when we talk of the OSI model, we're talking about these 7 different layers, and we're talking about TCP IP model. We're talking about these like 4-ish, 5-ish layers. And what I had referenced yesterday, or what I had said yesterday, is kind of like taking your message, putting it in a box, and putting it down a layer, and then putting that whole thing in a box, and then putting it down a layer, and putting that whole thing in a box, and putting it down a layer, until you get down to the physical layer, where it's like really just raw data, raw signal, and then finally re-encapsulating that back together. So like, what does that mean? Here's one image of it. I personally don't think this is the best one, but I think this is a good, just one of them. So at the blue, you see, there's the MAC layer, and it says PDU, or Protocol Data Unit. Just look at the whole blue bar being inserted into the physical layer bar, right? Oh, that would be the signal. So let's actually take a look at how this looks in, this is where I want to be. So here's that TCP IP model. Right? I want us to take a path down from the top down to the bottom. So at the top, you see this number 5, the application layer. Let's use HTTP as an example of our application layer protocol, right? That is the web protocol. We've been introduced to it a bit, and we're definitely going to look a little bit more details into it in the future. But for now, what do we know about HTTP protocol? What kind of stuff does it give us? What type of files does HTTP generally give us when we're trying to make a website? There's 3 kinds of them, of those files for reference.
Is it HTML, CSS, and Java?
Yeah, so JavaScript. And I'm specific about that because I guess like, as car is to carpet, Java is to JavaScript. They have like similar names, not even the same. But yeah, so we grab those 3 types of data, and we're going to use the HTTP protocol on that 5th layer to send that. Below that, we have to wrap that whole message up inside the transport layer. So this is where, if you look on layer 4, on that number 4, we're attaching a source port and a destination port onto that message. Now you see the source port is very high number. It's like 31,244. Those are high number ports, and those ports that are really high don't last very long. They're generally temporary ports. If you'll notice, the destination port over there is port 80. And if you remember, HTTP usually runs on port 80. So HTTP servers are usually listening for requests on port 80. Okay. So now we have all that message. We wrapped it up in, or put a header on it that says source port and destination port. We're going to take that whole thing, basically another package, and we're going to wrap it in another box. This is the network layer box. Essentially, we're adding a source IP address and a destination IP address, right? All of that other information is encapsulated within there. We call that whole thing a packet. And then Go down one another level, we have the MAC layer, the physical layer, right? We have a source MAC address and a destination MAC address. Who's sending this message? Where is it going to? And that all gets encapsulated. And then finally, we have the physical layer, which we're not going to talk too much about. You know, I don't know if you're an engineer or physicist sort of person, really like talking about signal and how you can hack from at that level. We're just not going to go in there. And it's really these upper four that we're going to spend most of the time in this program talking about. So at the top, we have application layer and its data. Encapsulate that to the transport layer where we'll throw on a source port and a destination port. Encapsulate that to the network layer where we put on source IP address and destination IP address. And finally wrap that up in the data link layer or the physical layer where we have a source MAC address and a destination MAC address. Okay, so this is kind of similar to that previous image where we're just like wrapping things up. You can imagine taking a message and putting it in several different envelopes that kind of have different addresses, source and destination addresses on them. Let's look at another image of this. So I like this image a lot too. Here we have the layers represented in OSI and the layers represented in TCP/IP. And what I think is kind of nice here is on the rightmost side, we can kind of see some protocols and like where they live in this entire stack of protocols. So if you notice at the top in that orange box on the top right, you have POP, DNS, HTTP, a whole bunch of things. HTTP, right? We're familiar with that. That's the one from the web. POP, that's a mail email protocol. DNS, we talked about that. All of those are living there, and that's all they worry about. Right below that, we have the TCP and UDP, right? That's where we attach those source ports and destination ports. Right below that, you see IP, right? The internet protocol. That's where we attach IP address, source IP address, and destination IP address. I'll mention ICMP, that's ping, right? That's the way your computer pokes another computer's IP address and says, hey, are you awake? There's the ARP protocol, address resolution protocol. That's the protocol that maps a IP address to a MAC address, right? Say, hey, what a ARP protocol is to tell you, hey, this IP address matches this MAC address, right? Makes sense. And then DHCP, that protocol assigns MAC addresses to, assigns MAC addresses and IPs. And then bottom, we have the data link layer. So this is all protocols that deal with the physical addressing. So big thing I want us to have in our heads is that we're taking our messages and it's like we put them in successive envelopes to bring them up and down this stack to transmit it. And I think that right now it's like kind of nebulous. It's like out in the clouds, this whole idea. But once we kind of actually take a look at what this looks like in real time, it'll make a bit more sense. Here, I just want to show you that a protocol data unit, how much data you can actually send. There's a limit, kind of like you may have heard that the internet is like a series of tubes, right? There's a limit to how much we can send through at a time, which is why we often will break things up into smaller packets, right? Now, there is some cost associated with splitting things up, right? Every time we split things up into smaller pieces, we're going to have to add more and more headers. So you see each data byte that we're going to have to split up, that 1,000 bytes that we're trying to send, we split up into 4 different fragments. And each one of those fragments is going to need its own header. So a combination of encoding and physical limitations, right? How much data can we actually send over a physical medium, right? At the end of the day, something has to interpret those ones and zeros that that signal that's being sent. We're not going to worry too much about it, right? This is why we have this OSI model to abstract those things away. But it's important to know, right? At the end of the day, something has to interpret these electrical signals to do stuff. Cool. And then oftentimes, right, data has to be split into packets or fragments because, right, there's a limit to how much we can send over the wire at a time. So let's talk about actually sniffing these packets. What does this look like, Matt? Right? We're talking ideas. I want to see stuff, and we're getting there, right? So we're going to talk about packet sniffing, right? And it's kind of what it sounds like. We're going to sniff these packets and kind of actually take a look at what they smell like. So they're in an encoding format, and we can piece them together pretty easily. And the big tool that we're going to use, it's super cool. It's got a great GUI, and there's a command line version. It's Wireshark. I mean, it already sounds cool, right? Wireshark, come on. Got a great logo. We're going to take a look to how to use it. First things you do with it are you choose what network you want to be sniffing on. We filter out what we want to listen to or what we don't want to listen to and focus on what we do want to listen to, because as you can imagine, there's a lot of data being sent over the wire, and not all of it is interesting to us. We set what type of filters we're going to capture, so what data we're actually going to capture with Wireshark, and we set filters for what we're going to display on our screen. A lot of this work in analyzing traffic is looking through a haystack for needles and getting particularly good at that, because a lot of junk happens as a lot of things travel over the wire. The types of the files that we're going to be looking at are called PCAPs, or packet captures. I think there's a new type of packet capture file, like packetcapture.ngl or something. I don't quite know what the differences are, but Wireshark will be able to open and read both versions, so don't have any worries there. Encrypted traffic, not all traffic we see with Wireshark is going to be readable to us. Some of it is going to look like a whole bunch of gobbledygook. Some characters are not going to print. It's going to be scrambled. So yes, we can read what's being sent, but unless we have a way to decrypt it, it doesn't really do too much for us. We can we'll be able to tell who is sending the message to who, and we'll be able to tell how much information they're sending, but we won't be able to actually read what that information is if it's encrypted. Encrypted protocols are very useful, and they kind of live in that application area. If you look at the OSI model, they specifically give a layer for it. I don't think that we need to mention too much about the using SSH for it right now, though. Okay, so let's actually play with Wireshark. Let me close what I was doing. Quit without saving. Yes. Okay. Cool. You can all see my screen here. Let's just open up Wireshark. So there's two ways you can open it up. You can either just type it into your command line like that, or if you're in Kali, you can just open up here and in the search bar Wireshark. There's two versions. I forget what the difference is between them. It doesn't matter as far as I've known. So this is what it looks like when you open it up. And then the first thing you're going to want to do is choose what you're going to capture. You'll notice here there's a whole bunch of different capture filters here that I can listen to. There's the ETH0 capture filter. That would be like if I do IP-C adder, right? I could see my devices. Here's my loopback address, right? That's my card there. My ETH0, this is the one I probably want to listen to. It's the one that has my IP address here. So I could listen to the traffic that's going across here. So let's do that. Okay. As soon as you do that, it's going to, well, let's take a look at what actually is on here on the screen. At the top, we've got a nice menu bar here. There's some pretty interesting things I'd like to bring your attention to. Obviously, there's a ton of Wireshark. So I'll just show you some highlights. Under statistics and conversations, this is often sometimes something interesting. Right now, I don't have a lot of traffic because I'm not actually doing anything on this machine. But you can usually click statistics and conversations to see some general statistics of what's happening in this PCAP file. Who's talking to who? So here we say MAC addresses. We see packets that have been sent. We see the bytes. We said A sending to B. Right? How many bytes A is sending to B, how many packets, at what time, when they were doing it, all sorts of information, general statistics there. Additionally, we've got this nice bar here. I'd like to bring your attention to the shark icon. Right now, it is highlighted gray. It means it's currently capturing. Stop capturing. Right now it's blue, so I can start capturing again. And if you stop and press this, it'll reset the capture. So it'll ask you if you want to save. So let's do that, right? So it's asking me if I'd like to save after starting a new capture. I don't really care, so I'm going to continue without saving. If I wanted to restart, I would again hit that button, and it does the same thing. Okay. Next thing I'd like to bring your attention to is this little magnifying glass. I don't have anything. It won't do anything now. Let's generate some traffic, huh? That'll make it more interesting. First thing I'll do is let's ping 8.8.8.8. So this will send some ICMP, some pings to this 8.8.8.8. And as you can see now, I'm starting to capture those. Let's stop capturing because otherwise, like I said, you get a lot of stuff. Okay, so let's bring your attention to the three main, these main portions of the screen. At the top, we have here the packet list. These are all of the packets on this, this top area. You see the number of the packet. They're all numbered in sequential order. They give you the time from when the packet started. I think you can change the setting of different times too. If you don't want to see when the packet was started, you might want to see, you know, time from the previous packet, something like that. You can see the source and destination, and we can change how we're representing the source. Right now, it's looks like it's showing it as IP address, but maybe we could change it. It's telling what protocol it was using right here. Here's ICMP or the ping protocol, like poke, poke, hey, are you awake? And then there's some info here. This is usually something interesting that we might want to check out, right? What is this? This is a ping request and some information in there. Next up, this second part is called the packet details. So if you'll notice, if I switch switch what I'm highlighted here, the rest of the information in this panel and in this panel change. So let's look at this one. Let's see. This one, right? This is me, 192.168.40.191. That's my IP address. That's my IP address. And I am the source. And to the destination, 8.8.8.8. This is one of Google's DNS servers. I'm sending a ping like, hey, are you awake? 8.8.8.8 responds with a ping, a reply, and some information. So let's look at this second panel. I think this panel is kind of interesting because it really relates to that TCP over IP model here. If we look at this level, we can open up here and we see the frame. It actually has the raw bytes and the encapsulation information. It's an Ethernet frame. Not as interesting. Let's go to this level. What do we see here? A source and a destination. What information is this? These 6 set of characters. You guys see what I'm talking about? What are those?
MAC address.
Right? These are MAC addresses. A destination MAC address, a source MAC address. That's all wrapped up under the internet protocol right here. You can see source source IP, destination IP. And then there's some additional information here we're not going to get too much into, but you can look at it in here. All of the flags, the headers, and that stuff. And then finally, we have the actual, where the thing is here, the Internet Control Message Protocol, the ping itself. Now, we don't see anything above that because if we go back to here, right, ICMP only lives at this network layer. So we don't see anything with ports, do we, right? If we go back here, I don't see anything with ports. It goes only up to ICMP. So let's do some traffic where we'll see some ports. Let's do some regular old surfing the net traffic. We're gonna continue without saving, okay? Brand new. Just gonna open up a browser and I'm going to go to example.com. Okay, and now let's do something else too. I'm going to go to the site http://bin.org. This is a site where that developers use sometimes to generate some requests so that they can test their APIs, right? So I'm just going to make a request for an image, right? It just says get, try it out. Let's try out making this request. I'm going to execute it. And then I'm going to look for that, right? I'm going to look for this request inside this capture. So let's stop capturing. And one thing I do want to bring your attention to is there's a lot of information here. I was capturing for what, 30 seconds, 40 seconds. I only had one tab open. You can imagine some of the PCAPs you get are going to be absolutely enormous. And a lot of the work you're going to have to be doing is filtering out the noise. So I wanted to show you some HTTP traffic, and that'll bring me to this nice little bar right here. This is the display filter bar. It will change what Wireshark is displaying to you from this packet capture. There are all sorts of great great ways you can kind of model your query to adjust what is being displayed. So for example, if I only wanted to see all of the traffic generated by my IP address, I can type in ip.source. And I love autocomplete, guys. I hope you guys have started to love autocomplete too, because it really helps, right? So I could see ip.source equals, and then what's my IP address? I can't remember it. This. Copy. Let's paste it here. You'll notice too that this bar changed from red to green. When it's red, you do not have a display filter that Wireshark is happy with. When it's green, you can use it. So if I hit enter now, it's going to show me, you'll see here, if I look through all of these sources, they are my IP address. This is all traffic that I generated in that time, to other things. Let's see what I did. Here's DNS, right? A standard query to DNS. So I probably needed to look up, translate some URL into an IP address over here. I see some TLS stuff. Is anyone familiar with TLS? Anyone heard that?
Transport layer.
Transport layer security, right? This is one of these protocols that's going to be doing some encryption for us. I see the TCP protocol. I see some DNS. I see this OCSP. This is usually associated with HTTP and something with getting certificates, so you can have encrypted communications. Okay, just scrolling down here, taking a look at all the things we see. You could see I've generated a lot, like a pretty big PCAP, just from really doing not too much. So that's that. Let's look at HTTP. If I type in just HTTP, I will see all of the HTTP traffic. That's pretty cool and pretty handy, and usually what we might want to be looking at a lot of the time, because most people, when they use the internet, are using their web browser and using HTTP to transfer information. Not always, but it's the most common one. Okay, so let's kind of take a look at what else we got here. We have all of the HTTP. Right, we can look through here. Let's look at where I made that GET request for that image. Well, let's actually look at all the HTTP we did here. Here was that GET to / right? The IP, the source address is me. The destination request was this 54236, whatever this is. I'm going to assume, right? It says it's Hypertext Transport Protocol, and it was sending it to, right? You could see this here now, right above the internet protocol that says our source port and destination port. We have the transmit TCP, right? There's the source port and destination port. Or excuse me, yeah, source port, destination port, source IP, destination IP. And then right above that, we have HTTP, Hypertext Transport Protocol, right? That's this. So if I click this, this is what we're looking at here. So if we want to just examine HTTP just a little bit more, we're going to be looking at it very closely in the future, but we'll also look at it a bit more. Here it says host, so this was going to httpbin.org. It says user agent, right? So we attach this header. It says that I was using the browser Mozilla. It says that my operating system was Linux, right? I was using Firefox. What type of things I'll accept, what type of encoding sort of stuff. Right, so let's find that. Let's find where that PNG is that we made here. You can see, pointing at the screen like you can see. Source port, destination port, HTTP. Here was where I made a GET request for that image PNG. And I can look at all of the details of this specific packet right here, right? From frame to the Ethernet, to the internet protocol, to the TCP, to the HTTP that sits above it, right? Do you see how these things are kind of stacked? I know it's like in reverse order than the other image we were looking at, but I want you to see that everything is just stacking on top of itself. And we're just adding like a little, this is from the source and it's going to this destination. This is from this source port, it's going to this destination port. And they all stack on top of each other here. Now I didn't mention this bottom panel. I find it to be the least useful generally, but it has uses. It is the raw information. So if you go here, you can actually see it's the packet bytes. So you can click here, and then this part of it, this whole thing right here is the whole raw encoded data. If I look and highlight this part, this information is encoded by that. You can kind of see it gets highlighted as you mouse over, right? So that is that. That is that. Not as important, like I said, but this is the raw information that you see there. Cool. I mentioned this little magnifying glass up here. It brings down this menu, and it's your Control F essentially. Super useful for when you're searching for things, right? So let's say if I was looking for this HTTP bin, right? So I could just search HTTP bin as the string. I'm gonna get rid of this so it doesn't even have that filter, and then find no packet has that string info in its column. Oh, because I typed it wrong. And check in the bytes. It's not in the bytes. It might be in the details. Yeah. So if I check in the details there, it's going to search through the entire PCAP and look for essentially this string that says HTTP bin. You might be looking for a different kind of string depending on, you know, whatever it is that you're looking for. But if I were looking for HTTP bin, it would point me to this packet. And then I could, you know, do some more research, like what was happening here, who was sending this traffic, yada, yada, yada. So when you're searching that Control F, you can search in here, the packet list, which is essentially searching this top panel. You can search the packet details, which searches this middle panel. And you can search the packet bytes, which searches through this bottom panel, raw data. You can search narrow and wide. So this is essentially what encodings you're going to be looking through. I don't usually change this. Narrow and wide seems fine for me for most settings. Case sensitive, right? You guys know what that means. And then finally, how is it that I'm searching through here? If you're searching by the string HTTP bin, that makes sense. But you can also search by other ways. You can search by the regular expression. You can search by particular hex values as well. Cool. All right. Next thing I want to say, we can click through here and we can actually follow the entire conversation that was happening. So I'm going to just close all these filters and start at the beginning again. I'm going to type in just HTTP. And I'm going to click this one, right? This is me, 192.168.40.191, making a request someone to 54.236.246.173, some HTTP request. And I can right click it and I go down to follow. And I can follow the streams. This is really useful. I can either follow the TCP stream, so like at the lower level, or I can follow the HTTP stream, what was being sent over HTTP. This is, these are both useful. Let's look at the HTTP one first. Okay, so what we see here is one, it's color coded, which is great. At the bottom, you can see it says client is in red and server is in blue. So that's really great for color coding this conversation. And it looks like the client in red made this request, this HTTP request. It said, get whatever is at slash on httbin.org. Get me that, give me that, please. And here's some more information. This is the HTTP header. This is the HTTP response, right? He said, okay. Here's some information, right? When are we doing it? And then here is the actual data, right? You can see, what is this? What does this look like, guys? I know it's maybe a little small. I'm trying to make it bigger, but I don't think I can.
HTML.
It's HTML. That's the raw HTML that our browser got, and that it reads it and interprets it and makes it look, makes it show and render on our screen. You can also see the style sheet right there. Right? This is the entire response that I got from that server. Let's see what else it has here. Pretty big response. It sent a lot of information for me here. You can see some JavaScript in here, right? I see a script tag. I see some JavaScript going on. Right? And then it looks like I sent another request for this. And that was the end of this conversation. Okay. I can follow, now this, you'll notice here, when I followed the stream, my display filter changed. And now says tcp.stream equals 6. Oh, that's interesting. You can change what stream you're going to follow here by just changing which one it says. So TCP stream equals 6. Well, what if I wanted to look at TCP stream equals 1? Well, this is what the first stream would look like. Same thing with 2, same thing with 3. I can follow them all and kind of see what was happening. You kind of got to play a bit like a detective and kind of pull apart a tangled up web here of what's going on. And you'll definitely feel like that putting on your detective hat on as you do some of these challenges of looking through here. So there's a few more things I want to show you guys before I show you another tool. The last thing I want to show you is how you can pull out certain files from, or export certain files from a PCAP, right? Now, if you remember, when I was browsing the web here, I made a request. Where did I do it? I made some sample request for this image. I think it was this little pig, right? An image/PNG. I made a request for that. Now I want to find that inside here, and I'd like to export it so I can have that in the file. So there's a couple of ways I can do it. Does anyone have any idea?
Can I ask a question?
Sure.
When you say that you requested the image, that wasn't any sort of a separate command. The image was requested because you went to the web page. Is that correct?
So yes, when I hit this button that says execute right there, it will make a request for that image, for this little piggy image. And now, since I captured that traffic, I want to find where I made that request. And I'd actually like to find that piggy and pull it out, right? It must be in there. So let's take a look here. We can search by string. That might be useful. And we know that it was a request to /image/PNG. So let's just copy that and see what comes up. So we don't find anything there in the packet bytes, but let's look in the details. Find anything there? Find anything in the packet list? Don't find anything there. Oh, it's because I have this display filter. Let's try that one more time. Cool. If you noticed, I had a display filter up here. So when you're searching, make sure you're searching the entire thing and not just what you've cut out. So it found exactly and highlighted for me right here. This is my IP address. This is the destination, and it's the HTTP protocol, and it was that /image/PNG. So what I'll do is I'll just follow it and follow TCP stream. You'll see that it updated my capture filter here. And you'll notice here I'm looking at this entire conversation. 2 clients, 2 servers. I make a GET request. I get a response. There's some stuff here. There's some stuff here. Right? This looks like some kind of JavaScript. But I know somewhere in here there's like a, yes, this is what I was looking for. Okay. This was that request, specifically that request for that PNG image, right? Here's the host, http://bin.org. Here's the resource I'm asking for. This is just the additional stuff that HTTP wraps up in the header. This is the response that I got from that request. Okay, here is your image. But you'll notice it is encoded in such a way that I can't really read it, right? This is, it's an image, but it's encoded, so I can't read this. What I can do is this. This is the nifty trick here. I'm going to go to File. You're going to export objects. And you'll see the different ways that ways that files can be sent that you can export things. So there's HTTP, right? We can send files over HTTP. You can send files over SMB, send files over TFTP. So we're going to go to HTTP. And it'll find everything in there. I'm pretty sure I feel like there should be more. No, I was looking at a different PCAP. So it shows you here exactly all of the objects you can export that were in the HTTP. I generally find it's useful to sort by size. And then we can take a look at what is it that HTTP sent us? What sort of objects did it send us? So one, it sent this 41 kilobyte thing. It tells us its file name. Tells us what type of content it is. It says application JSON stuff. Here's some text that it sent me. It actually shows you the specific packet that it gets it from too. You'll notice if you're looking in the back, it changes what I'm looking at. But here is the one I want, http://bin.org, right? That's the host name, the image/png. It's about 8,000 bytes. That sounds like reasonable for a small image. And all I got to do is click save. And I get this nice little GUI. It'll tell me where do you want to save it. I'm just going to save to desktop so you can see it right here. Cool. And then it saves to desktop, literally right there. Here's my little piggy PNG. Okay, cool. So quick recap on the important parts of Wireshark. Okay, Wireshark is used for capturing traffic. We can turn it on by just clicking that button right there, and it'll start capturing traffic. We can capture, we can choose what we want to capture and choose what we want to display. It's like filtering two different ways. Choose what you're going to listen to, and then filter from what you're listening to, what do you actually want to see? Because like I said, it's like looking for a needle in a haystack sometimes. We took a look and saw here that there are 3 main panels that we'll be looking at. We have the packet list, we have the packet details over here, and we have the packet bytes. The packet list is really cool because it shows us every single packet. It shows us some important fields that we might be interested in. The second here, the packet details, we got to pretty much see this OSI model / TCP IP model like right here. We're literally seeing it now. We're seeing how everything kind of gets wrapped up in another box and another box and another box. Okay, and then we see the raw information here. We learned quickly how we can kind of do the control F, right? Searching here by either string or regular expression. And we learned that you can either search the entire packet list, you can search the packet details, or you can search the packet bytes. And finally, when you want to actually export some sort of media that is found inside a PCAP, it's very easy. It's actually just file, export objects, and then choose from what you want. Now, for example, say I went to like DICOM, there's actually nothing there in this PCAP for DICOM, right? But if I go to export objects, I don't think there's any, I don't think I had anything else in this PCAP. So I would only be able to pull out from there, and then I can save. So that was a really fast tutorial on Wireshark. Do we have any quick questions? We're going to be playing with this for the rest of the day for sure. But I think what's most important is that we kind of at least have some mapping from like, oh yeah, this OSI model, I'm seeing it right now. I'm seeing it right there. So I'm just going to leave this like a quick 1 minute for anyone to gather their thoughts and ask a question before I show you the new tool.
So the packet details, the middle list.
Yes.
So it starts from the higher the level, the lower it is on the list.
It's, yeah, it's a little bit reversed from that other, right? You see it like here, you see application at top, and it's like flipped upside down here. Right. So here's the HTTP protocol. Right. Below that, you have TCP with the source port and destination port. Below that, you have the internet protocol with the source IP and destination IP. And below that, we have the source MAC address, destination MAC address. And below that, we have like the raw data sort of stuff that I don't generally look at too much. Does that answer your question?
Yeah.
Yeah, I was a little confused because it's like reversed.
Okay.
Okay.
If you're looking at HTTPS traffic, does this still show up, or is it somehow not visible?
Yes. So great question, actually. If I'm looking at HTTPS traffic, it's going to look like when I showed you that PNG image. It's going to look like this. You see all this, where characters are not even showing. It's going to be gobbledygook nonsense to you if you look through encrypted traffic. And that's the whole point. They'll be able to see it. They'll be able to see how much. They'll be able to see where's it going and where's it coming from. But you can't actually tell what the message is. Great question. All right. Cool. We're going to be doing some problems with this. Let me show you the other tool that you're going to be needing to solve some of these problems. I'm going to quit without saving. Does anyone? No, I don't think we need a break. We can just go right to it. Let's close these tabs. And so the other tool I want us to become familiar with is called NC, or NetCat. It is a fantastic Swiss Army knife of a tool, and you use it really for raw TCP IP connections. Okay, so what I'm going to do right now is use NetCat to listen on my machine, and then use NetCat to reach out to my machine. So let's do this way. I'm going to split my terminal into two. Okay. I'm going to say nc-help. Actually, I don't want to show you that one. My NC is a little bit different. Okay. nc-l to listen, v for verbose, and P for port. These are the most common flags you're going to be using with NC. I'm going to listen. I'm going to say D verbose with what you're telling me, the, and I'm going to give it a port number. I'm going to listen on port 1337. Right now, my machine is listening on port 1337. Okay. On this side, I'm going to also use NetCat, and I'm going to reach out and talk to myself on that port 1337. So I'm going to say NC, my IP address. I'm going to use my loopback address, 127.0.0.1. And I'm going to give it the port number that I want it to reach out to, 1337, right? Because that's the one that's listening. Nothing happened yet. Well, on this side, because I gave it the verbose flag, it told me a little bit of information, but nothing really happened. All it's saying here after it was listening was that I got a connection from myself on that port number. You'll notice NC picked one of those high ephemeral ports to reach out and contact me. So what can I do with this raw connection now? I send information over. That's what I can do with any kind of connection, right? So I'll say, hey, hi. Hey, hello. Are we impressed yet? Can talk to myself on my own terminal. Cool, right? You'll have to take my word for it, though. I didn't set up two VMs on the same network. I could do it like that and talk to myself that way, but it'll look the same, and you guys would be just as impressed, I'm sure. So this is what we can do with NetCat. We can use NetCat to set up listeners on our own machine, and we could use NetCat to reach out to other machines. Let's do that. Let's use NetCat to reach out to another machine. NC, let's say example.com, and let's do port 80. Nothing happened. This is because all NetCat's going to do is reach out and establish that connection. It's not going to send anything. It's not going to do anything else. Now, I know example.com is a web server, and I know pretty much how HTTP works. This won't work exactly like I wanted in the demo, but it'll work similarly. The way HTTP headers work is you kind of say, what do you want? And I'd say get slash. So get me what is at the root, right? Slash is root. What did I just get back here? What does this look like?
HTML code.
All right, we got some HTML code. It's not exactly example.com because example.com wants you to use, it's not implemented this HTTP 1.0 protocol, probably 1.1. But it did, as a server, respond to me. And it did respond to me with some HTML. And if I did ask for this as in a browser, it would be able to render this. But since it's just NetCat, it's just going to send me the raw information. Cool. What else can I do with NetCat? I can save things with NetCat, right? I can say, hey, let's save some things. Let's say nc-lvp, listen verbose port 1337. Actually, I want to do that. Can I do this? file. Yeah, test. Okay, so what I did here was just like you would normally do, NC LVP, and then send everything you catch over to test. Okay, and then NC 127.0.0.1, 1337. I say, hello, how are you? Blah, blah, blah. You'll see nothing's actually coming out to the terminal, right? Because where is it going? It's going into this test file I made. So let's look at that. Kill it. Cat test. And there's that information. Hello, how are you? Blah, blah, blah. So I can use Netcat to set up a listener that will save whatever gets sent to it to a file. Super useful to me, right? Super useful. I can use Netcat to set up a listener and say, whatever you send to me, save that in a file. Okay. What else do I want to show you with Netcat? How to listen, how to connect, how to save things to a file. I think that's pretty much all you'll need. Do you have any questions on Netcat or NC? Really? No questions? Like, why would I use this?
Yeah. Yeah. So how do you like? What do you gain from using Netcat for let's say to your own ports?
Cool. What do I get from using Netcat to my own ports? Great. So this is going to become much more apparent and much more useful in the red team phase. Eventually, we're going to figure out how to tell computers to send us their shell. And when they send us their shell, we want to be ready and listening for it. So that when we listen for it, it's instead of just getting back, hello, how are you, blah, 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 it's going to send us their command line. And then we have their machine. We'll use Netcat to reach out to ports. Netcat's really useful to just like make that raw connection and see what's on the other side, right? Like when I Netcatted to use Netcat to connect to example.com/80, I can just send raw data this way, get slash. Right? If I knew how to speak the HTTP protocol a little bit better, I could probably format this in such a way that I get the regular website. Let's see. Anything else I want to say about Netcat? That's pretty much the use cases that we're going to have for it. Setting up listeners and reaching out to different ports. I don't want to talk too much more about it and how Nmap uses it yet. Frank, do you think that there's anything I'm missing here, or are they just about ready now to try playing with these tools?
No, I think that's pretty much it. Yeah, the Netcat, the Wireshark, like that should be kind of apparent, like the uses for that, right? You're looking at network traffic. It's like a log, a capture in time of network traffic. The NC will become clearer, like you said in red team, and it'll become not only will it be more clear like what you're using for it, but it's like indispensable. It'll become like one of your main tools that you're going to be using. So
yeah, Netcat's fantastic. You're going to be using it like it's great, nice little Swiss Army knife of a tool. And really the way you can think of it working is it makes one of those TCP IP just raw connections that you can send whatever you want back and forth, right? So all you need is a IP address or a domain name and a port number to make those connections. All right, cool.
Matt, sorry, there's a question on the chat.
Sure, let me stop share and read it. If we are using Netcat to talk to ourselves, can we see the data on Wireshark? I believe you should be able to. Yeah, you should be able to.
yeah, you can.
So yes, you can try that for yourself. Send yourself some files over it and watch yourself source, and destination IP addresses will be the same, but the ports will be different. I'm just going to look through these, see if there's any other questions.
Just jokes.
Okay. Just jokes. Just jokes. All right. So if no one has any questions, that's
Actually, I have
fine.
a question, Matt.
Good. Shoot.
So you've been doing this really nifty thing with your examples where it looked like you've split your terminal in two and got two different spaces there. Do you mind explaining to everyone how you did that?
Sure. Let me share my screen real quick. So I use this nifty terminal program called Terminator. The only reason I like it is because you can right click it and split your terminals however you want them. Sometimes this is useful, like, you know, you might have several things going on and you want multiple terminals and you want to see things on screen. So the way to get it is you just, open up your regular old terminal and you get things the way you get them in Linux, right? apt install Terminator.
But for what you're using, I think the regular terminal can do the same thing.
Oh, can it?
Yep.
Is it just right click split? Oh yeah, it can. I don't think that, did that always have that?
Yeah, as far as I don't know if it's always a right click. I think it used to be in a menu in 2019, but it was always there.
All right.
But
Well,
you also have cool colors.
oh, so if you want my cool colors, at the end of the day, after like 6 o'clock, I'll stay for a little bit, and whoever wants to, I will show them how to set up the cool colors. It's a little bit different. You'll notice some things when I'm in my command line here, and sometimes this is annoying to me, sometimes it's not. Several things are already remapped. So like my LS is LSLA, and LL is LS, and show me other things. So maybe I shouldn't show that. I shouldn't do that because that makes it a little bit different and confusing. So there's that. So that Frank showed you how to split your terminal. You could still use Terminator if you want. I don't know. I like that it's clear, but you could probably adjust the transparency in the other one as well. Okay. So y'all can take about 5 minutes or just hang out here if you want. I'm just going to set up pairs and open us up into breakout rooms. We're going to be working on the, what is that called? The OSI model. Is that the name of the workshop? Or is it data transmission and capture?
Yeah,
Data transmission and capture. We're going to be working on that one. Just so that I don't get, just so that you know what to look for, the key to unlock the problems is in the workshop, but you gotta look for it. But just put in a help ticket if you don't find it after 10 minutes. I'm gonna unlock the workshop now so you can start looking at it. And then, like I said, give me a few minutes so I can split us all up.